For example 4, we have a problem. The bases are not equal. Now I said before that if the bases are not equal, we're done. But in this case, there's kind of a workaround that we could do. And the workaround we could do is we can make them the same base. So we could say that 9 is actually the same as 3 squared. So it's going to be 3 squared to the 2x minus 5, which is equal to 3 to the 18. Now the bases are not quite the same. If we have a power to a power, what we have is we have 3, we multiply it. So it's going to be 3 times to the power of 2 times 2x minus 5. And this one is just, of course, 3 to the 18. Now the bases are the same. So that means now the exponents are the same. So now we could say that 2 times 2x minus 5 equals 18. 4x minus 10 equals 18. 4x equals 28. And x equals 7. And that would be the solution to this equation over here. So what we did was the bases were different, but we changed the base to make it the same. Example 5. So this one's not as obvious. I can't write 8 as 4 to something. Well, I could, but not easily. So what I'm going to do instead is I'm going to put them both into a different common base. And both of these could be written as 2 to the something. So the 4 I could write as 2 to the 2. And the 8 I could write as 2 to the 3. And it's kind of the same bottom, and that's going to be the key there. That's x plus 7, that's 2x minus 10. And then I could do the same trick where I say, okay, 2 to the power of, so 2 to the 2 to the x plus 7, we multiply those guys. And that's going to be 2 to the 3 times 2x minus 10. Now the bases are the same, which means the exponents have to be the same. We could, we're going to expand these guys. We're going to get 2x plus 14 is 6x minus 30. And then we're going to get negative 4x is negative 44. So we brought the 14 over and made it negative. Divide both sides by negative 4, and we get x equals 11. Now these answers have been pretty, but there's no reason why it has to be pretty, of course. So I think we're on example 6. So if we have 9 to the 2x minus 1 equals 27 to the 5x minus 6. We'll do the same trick we did with the 4. We'll do a common base of 3. So 9 is the same thing as 3 squared. 27 is the same thing as 3 cubed. And that's to the power of 2x minus 1 and 5x minus 6. They're not quite the same yet. We've got to turn those greens, put those exponents away. 3 to the 2 to the 2x minus 1 is going to be 3 to the 2 times 2x minus 1, which is going to be 3 to the power of 3 times that, 3 to the 5x minus 6. Now the bases of the exponent are the same, which means the exponents themselves have to be the same. So 2 times 2x minus 1 equals 3 times 5x minus 6. 4x minus 2 is 15x minus 18. Bring the 15 over, we're going to get, I'm going to throw in an extra step here just because. Negative 18 plus 2. 4 minus 15 is negative 11x. Minus 18 plus 2 is negative 16. Divide both sides by negative 11, and we get x equals 16/11. And there we go. That's the solution to that equation over there.